Hello, and welcome to part 2 of our series on developing solutions with Azure Cosmos DB. This is Understand Key Design Decisions with Azure Cosmos DB, and it'll be a technical deep dive into several topics that are important for building a solution. You'll learn the key considerations that you need to understand in order to make sure your projects get started successfully. And our instructor today, once again, is Sri Ram. Thank you so much, Sri. Over to you.
Thank you, Matt. Welcome all for our second session in the three-part series. The session is Azure Cosmos DB for developers who are looking to develop their applications on Cosmos DB. So during our previous session, we actually saw various basic components of Cosmos DB, how to do a design, how to create a partition, etc. We also learned Cosmos DB is a multi-model database. There are different APIs available within Cosmos DB. So today's session is geared for developers who want to understand a little bit more about best practices in designing various applications in Cosmos DB. During the first part of this conversation, we will concentrate at a greater detail on how to design partitions, how to make the system a lot faster or your application a lot faster. And also we will look at various tools and technologies we use to access Cosmos DB. We will see what are various REST APIs available as well as SDKs available for us to create our applications or to transact with Cosmos DB. During the second part, we will look at Cosmos DB and functions, wherein we'll see how to create event-driven architectures with Cosmos DB, especially in the context of IoT use case. Also, we will see how to move the data in bulk from on-premises into Azure using change field library and other things such as data factory and what the differences are. We'll wrap this session today with a lot of demos around functions and what role functions play in event-driven architecture, especially working with Cosmos DB change feed. Throughout this session, I will be showing you various tools to access Cosmos DB as well. I would highly recommend you start with session 1 and finish the video over there so that you understand the basics of Cosmos DB before we dive deeper into this session. Let's go ahead and start today's session. So today's agenda, at brief, we spoke. Today it is mostly about how to actually work with Cosmos DB from your applications. Last week we saw how Cosmos DB solve your use cases around key values databases, column family databases, document databases, and graph databases. We will pick up Mongo API document database as well as graph database next week, in addition with Cassandra database, which is column family. But most of today's conversation will get towards the first party, our own API called SQL API. Our core API is what we call, wherein we work with JSON documents. So in order to develop modern apps, we need to have access to the data, especially the sub-second response when you are writing to the database or when you are reading from the database, for which you need to have a guaranteed speed at any scale that you operate your database with. So Cosmos, we saw how a less than 10 millisecond latency is possible at any scale with a construct called partitioning. And as you design your partition, you can actually create unlimited number of partitions to make your data set extremely large. And also the modern applications should be mission critical, which means it needs to be available across various regions, so that if for any region there is if there for any reason there is an outage in one region, you should be able to point your users to the next nearest region. We also saw how we can configure uh, multiple write regions and read regions to ensure the mission critical readiness for your app. So also app development is very important as well, and we will dive deeper into various APIs and SDKs that are available for a developer's use. Uh, as I mentioned, so this conversation is towards core SQL API, and please stay tuned for next week video so that you can know at a greater detail of what a MongoDB API and a Cassandra API in addition with Graph API on Cosmos DB. Let's start today's session with a brief recap of partitioning. We saw partitions are of two types, a logical partition and a physical partition. As Cosmos DB is a fully managed service, Microsoft takes care of hardware components such as memory, storage, CPUs, etc. And these all are attributes of physical partitions. So as a developer, you actually are responsible for creating a logical partition wherein a set of logical partitions sit together on a physical partition. And therefore, it is very important for you as a developer to understand how to design such a logical partition and understand the characteristics of the physical partition so that you can make a prudent decision of scaling, etc. Let's actually go through some constructs of or some properties of the physical partition and logical partition so that as a developer, you know what the ground rules are to make your decisions. Each physical partition is 50 gigabytes in size, which means if your data crosses 50 gigabytes, then we automatically spin another physical partition. Each physical partition is assigned 10,000 request units. We already saw what a request unit is. Again, for those of you who are joining this call directly without going through call one, an RU is the RUs are nothing but the unit that can read 1 kilobytes of data. So let's say your document is 1 kilobyte. It will take 1 RU for you to read that document. At the same time, in order to make a write, it might cost more RUs, right, of a same 1 KB document. To perform an update, it might take some number of RUs. So RUs are like tokens for you to go and operate on Cosmos DB. So as you can see here, every physical partition is limited to 10,000 RUs per second. So you need to understand as you are querying across partitions, which we called it as a fan out query, you are actually reading from multiple partitions. And what if every partition is limited to lower RUs per second, which you will see very soon of how that can happen. So we need to make sure we actually understand the characteristics of a physical partition while designing our logical partition. So logical partition can have 20 gigabytes. And when you are creating a new collection, the number of physical partitions that are assigned for that collection is based on the formula of ceiling of request units divided by 6,000. So what that really means is, let's say you demanded 50,000 RUs for your collection. Let's say 60,000 RUs for your collection. So the number of partitions it will create when a new collection is created, according to this formula, is 60,000 divided by 6,000, which is equal to 10. Okay. After we understood these rules, now let's see a real-time scenario and see what are the various pitfalls we could avoid while designing. Assume that we demanded 30,000 RUs for our collection. Assume we have a partition key that has a value. As we all know from last week, whenever we try to insert a document into Cosmos DB, every partition value is hashed. And if the partition key value is same, it is always going to be hashed to the same value. As you are seeing here, let's say your value ABC, if it is always hashed to the same hash value, so the documents corresponding to ABC 1, 2, 3 all sit in same place like so. So this is how we achieve distribution. And as we know, since we demanded 30,000 RUs when we create this collection, we spin 30,000 divided by 6,000, which are 5 partitions. And let's see, as we start filling up this, we start writing the hash values to different physical partitions. And as you can see, right, the distribution is more or less uniform. And now the physical partition number 2 reached 99%. So Cosmos automatically creates another physical partition for you. And now it will split your data across the new partition and the old partition like that. So let's take the scenario wherein you demanded 300,000 RUs when you created the collection. And one of the reasons that you might do something like that is you can think that you have actually a larger number of partitions here because 30, right? And now you will also assume that, which is true, that if you try to insert data at larger volumes, let's say during your first historical load, you will use all 30 partitions and would be able to load the data very quickly into these partitions, right? And that is based on what we spoke about partitions. But let's take a look at whether this is really a good idea to do that. So let's say it took 2 minutes to load into a 300,000 RU collection. Now your loading job is done, and let's say you want to scale down your RUs back to 30,000. Because the reason you did it is you don't need like 30 partitions to store your data. So you had a very good intention of lowering the cost, and you did that. But please note, just because you scale down the RUs per second, your physical partitions will not come down back to 5. They will be 30. And guess what? Since we have the rule that every single partition will get same RUs, now every single partition get 1000 RUs. And now imagine if you had only 5, you were supposed to get 6,000 RUs. And now you are left with 1000 RUs. So your query now is going to run 1/6 slow as before. So this is one of the common pitfalls I want to bring to your attention so that you don't make this mistake of scaling it very high for write workloads and take the penalty on the read workloads. Instead, what I would do is I would let my system be at 30,000 RUs, let for the historical load run for 40 minutes versus 2 minutes, and I will get consistent read performance. So this is actually the cautionary tale. This slide summarizes what we have seen thus far. So assume again to reinforce our learning, assume the user provision 10,000 RU per second, which means they get 2 physical partitions. And now let's say each physical partitions get 5,000 RUs. And now suppose there is a very hard partition. So what that means is really you chose a very bad partitioning key, and like you actually are sending the data only to one single node versus using two physical nodes here, right? And then you think, oh, okay, I'm not getting the performance. Let me scale it 10 times. Of course, you get the performance because you are paying uh, more, of course, though unnecessarily in this case. And now you got 10,000 RUs per partition. Great. Hard partition gets more RUs. But now let's say once you have performed your read operation, let's say this read operation happens just 2 weeks once. But your day-to-day operations will now be much slower. Remember, when you did 100,000 RUs per second, you are left with 10 physical partitions. And now when you lowered them back to 1,000 RUs for $58 a month because they are cheaper, now you are left with 100 RUs per second. So again, the cautionary tale is just because you want to get a single time read performance, maybe I would revisit the design of the partitioning key to avoid hot partitioning versus you trying to scale up and scale back down. So this reinforces our learning on how to actually design logical partition so that it does not lead to a hard physical partition. Now, let's see what if we scaled in the previous scenario to 20,000 RUs. Now there are two physical partitions and each partition get 10,000 RUs. And it is what it is, right? So you can make it okay. You cannot avoid the hard partition, but still you get 10,000 RUs on that partition versus 5,000 before, and your query will be 2 times faster. And let's say when you scale it down, you get consistent distribution of RUs between those two partitions. So just again, a note of caution. So with those two advanced design concepts and with the other concepts you learned in session 1 on how to design a logical partition and what are all the best practices for designing such a partition key, we have seen the win number as partitioning from our previous episode, wherein you have done embedding, you have done denormalization, etc., to make your Cosmos DB collection much more partition friendly, much more faster. And now let's jump, since we understood all the basic concepts and advanced concepts of designing the Cosmos DB partitions, we will jump into the code and see how do we write the code in order to talk to Cosmos DB. So Cosmos DB has a REST API. So in fact, Cosmos DB provides REST APIs, right? We provide two different kinds of APIs, really important. The first kind of API is account APIs. So for account APIs, it doesn't matter which API you use, whether it is a core API or MongoDB API or Cassandra API, you can actually operate on your Cosmos DB account, such as dealing with the keys or dealing with account level stuff in Cosmos using these account APIs. You can also access Cosmos DB using a REST API, but that is only possible. For example, if you want to access a collection using a REST API, you can do so. If you want to access a document within the collection, you can do so. If you want to create an index, you can do so. All of these things are possible only for core API. This is the nuance I want you guys to understand. Having said that, these two REST APIs for working with resources in Cosmos DB, henceforth I will be calling it as REST API. And the second one that deals with account, I will be calling it as resource provider API. And that's how it is called even in our documentation. So resource provider API is used for working with accounts and keys for all kinds of Cosmos DB APIs. Whereas REST API, again, I'm repeating, REST API is available to deal with Cosmos resources and data only for core API. So here are the references in this slide wherein you can get greater detail about how to deal with Cosmos DB REST APIs and how to work with resources in Cosmos DB. Let's do a brief overview of the resources that are available in Cosmos DB before we jump into a demo. As you know, Cosmos DB is an account. Underneath the account, you can create multiple databases, just how you do in relational world. Underneath each database, you can create a collection. A collection is synonymous to your table in the relational database. A collection contains documents, just like how your relational database contains rows and columns. And the documents are JSON documents. We already saw them. And along with the documents, we have the ability to create stored procedures, user-defined functions, and triggers in Cosmos DB. So the stored procedure is exactly what you think it is. It's a stored procedure which operates on a row by row basis. For example, let's say if a row is inserted into a Cosmos DB, what exactly has to happen? A trigger is the same. And UDF is if you want to define your own functionality in form of a function, you can write a JavaScript wherein you can embed your logic, however complex it is, to create your own user-defined function. And I will show you a couple of a stored procedure with the user-defined function very soon so that you get an idea. Remember, this API is not suitable to deal with accounts or keys. And this is available only for core or SQL API. So let's actually now see how to operate this one with a tool called Visual Studio Code. So most of the developers these days know what a Visual Studio Code is. If you are new to Visual Studio Code is a very powerful tool to write your code wherein, for example, you can run C# code and you can operate on various components of Azure, non-Azure, or Dockers and many other things, right? So among which Cosmos DB is also one of the things. So for example, you can actually attach yourself to a Cosmos emulator, for example, in order to test out in your local system, etc. However, right? So I'm going to show you a C# example wherein this C# example actually is going to Cosmos DB account. This is the account which we have seen in the last slide, right? So this is called the account, and the account is accessible with the key. Okay. So now within that account, it looks like we have a database, and within that database, we have a collection. And within that collection, we have a document with an identifier of 30 and the partitioning key. So let's see how the document looks like in Cosmos DB. So let's go back to our Cosmos. And within our Cosmos, sure enough, we have a database called DB1. Underneath the database, we have C1. Underneath that collection, we have a bunch of items. And the partition key here is named as partition key itself. The partition key is partition key, just a small example. And the ID is 30. The identifier is 30 for this thing. So now let's see how we can use our REST API to access that. Let's go back to Visual Studio and look at some portions of the code. For example, all you have to do is you actually provide the Cosmos DB account endpoint and the key, and you use the Cosmos DB client that we have provided. And what you can do is, let me make sure I'm showing you the right portion of code. I'm so sorry about that. Okay, so let's first finish the REST API client and then go to SDK client. Okay, so we use a library called Cosmos DB REST API client, and everything else is same what I have shown you. And here we instantiate API client with the endpoint and the key. And once we have handled to the API client, you can use this REST API, for example, to list databases underneath the account, to list collections underneath the account, or to execute a query such as these, right? Select star from a collection where the partition key is the partition key that we are supplying, which is 30 in this case. Right. So let's actually go ahead and, when you submit a query, you submit it as API query.query async with the query information here. And I'm just printing here to the console just to make our life easy so that we can see this better. So let me go to my terminal and let's say open an integrated terminal. And now I am right here. Let's say .NET run. And sure enough, we got the stuff printed to our thing. Please see here, you get a rich set of information from its header. And also last week we spoke about how to see the RUs within this header. So if you scroll up, you will see information about. Okay, this is about execution info. Yes, XMS request charge. So here it is. Let me highlight that. XMS request charge. So this query took 2.95 RUs. Okay, so that's what it is. So secondly, we also saw you can run the exact same query here. So if you go to this query, let me just say, let us go to this collection and say that here we go here and say new SQL query, and we can actually say from C where C dot where C dot partition key equal to, let's say, 30. And you can go and execute this query. New SQL query. Let's do like this. Okay, so maybe the ID 30 is not there in this particular thing, but you get the point. This is how we can execute from here. And now I'm going to show you another tool. As I promised, I'm going to show you all the tools today. For example, let's say we can use this tool called Azure Storage Explorer. I'm not sure how many of you are using Azure Storage Explorer today. From here, you can actually everything within Cosmos DB and also perform the queries. Please note that once you go to the collection, for example, underneath this Cosmos DB account, I have a database called Contoso Auto. Underneath that database, we have a collection called metadata. So, and there are a bunch of documents here. And now here, as you can see, you can open a new tab, new query tab, right? So in which you can write the queries. So this is the collection from the last week where we have seen from our metadata collection, we want to fetch the one with win number of so and so. So you go and press execute query, and here are all the documents that are written. And the same exact information you can see from there, you can see from here, right? So for example, here the request units are 6.15 RUs. So please note that we have all these various tools, and I will point you to all these tools as we go through our today's journey. Like I mentioned, I promised I will show you a stored procedure. For example, this is a stored procedure and it performs an upsert. Okay. So let's say when it is performing an upsert, what it does is it is actually it will actually, as you can see here, right? This is all Java script, right? So the Node.js code. So if you actually are well versed with JavaScript, you can write this. So essentially, right? Here they define their own merge logic, right? From the source, how the stuff need to be merged, and what needs to be merged. So as you are going through this, right? You can see a bunch of Java code which is defined here just as a function, and we are calling that as a stored procedure, right? So likewise, if you see a user-defined function, oh, there is no user-defined function on this. Let me see if we can find user-defined functions on other collections. Okay, so let's take this simple collection. In this simple collection, for example, let's say let's take a common scenario, right? This actually drives everything home. So you have actually the collection, and you wrote a stored procedure called get item. When you are getting this stored procedure, what you are essentially doing is you are applying a user defined function like this. So in the user defined function, you are saying there is this thing called upcharge. So pass the amount, right, that is coming into this stored proc, apply the UDF, and then whatever you perform calculations using this UDF, right, you will make an action on that. I think in this simple case, we are just printing it to console, right? We are not doing much here. But if you go to this upcharge, right? So this is again a simple function, right? Again, JavaScript. It takes base amount and it returns base amount times 2.5. So if you were to run this stored proc like shown here, right? It also applies the UDF. So let us see that piece of code in action. So now let's go back and also see how we use Cosmos DB SDK, right? So that is the REST API I have shown to begin with, but now let's see how we actually use the SDK. Pretty much it is the same, with the only difference being uh, instead of using the REST API client, you will be using Cosmos DB SDK client, and Cosmos DB SDK client have all the various things that you have seen. And in this, there is this execute sproc async, and we are executing the get item, okay, as shown, as I have shown. And once I execute that, you write out the result in a very simple way, and it will calculate the upcharge. That's what we thought we'll do. So let's go here and see what happens in action. Open an integrated terminal. Let me do .NET run. Oh, let me see. Give me a second. So we will say SDK, open an integrated terminal. .NET run. Okay, hopefully it'll run, and sure enough, as you saw here, right, for ID 30, let's say the amount we passed inside is something, but whatever it has printed would be an upcharge. So it executed the sproc, it took ID 30, right? So let me see what ID 30 is. So for ID 30, we had the amount of 1.11. Now what it is supposed to do is the upcharge, it needs to multiply 1.11 with 2.5, I think what we gave, and sure enough, the retail price is upcharged here. So this is an example of how powerful the SDK is, so that you can actually write your own store procs, store procs and UDFs, and you can run those stored procs. However, after seeing this, now let's see when to use the REST API and when to use the SDK, because it is important that you need to understand that. So use the Azure Cosmos DB REST API if you are working in a language without an SDK. For example, what you have seen here in the Visual Studio Code is there is a C# SDK. Like that, there is a Java SDK, Node.js SDK, Python SDK, and all that stuff. What if you are using a brand new programming language, or some very old programming language where there is no SDK published? In which case, it makes sense to use REST API. Or when no other library driver or ORM is available, that makes sense. And for some reason, we need to avoid using the SDK. Okay. And especially this is true, right, in the cases where, for example, like you want to specifically operate over REST APIs. So for example, let's take an example of a bot. You are designing a bot with Cosmos as the backend. And as you know, when you are designing a bot in bot scenarios, usually you make many REST API calls so that you provide that one information to the user, right? Of course, I'm not proposing for you not to use SDK. You should still use SDK. But what I'm saying is maybe in those scenarios where you don't want to use SDK and just get away with a simple REST call, it is totally okay. And of course, when you are experimenting and learning. So when you need to, the flip side of that, let's see, when you need to use Cosmos SDK. Cosmos SDK, I would say you should as much as you can use Cosmos DB SDK, because our engineering team creates those SDK and they spend significant amount of dev test resources on that. They incorporate best practices in SDKs, such as retry logic, right? Checkpointing for bulk loaders. So which as a user, of course, you can write all the programming by yourself and do the exact same thing by yourself. But hey, why can't we actually use the existing resources and build on top of that so that we can make our life simple? And also, SDKs include very rich set of error handling and logging mechanisms, right? And parallelization, retry logic, when we are doing bulk import, these are all the stuff, right? Checkpointing, which we have spoke about. SDKs are open source and they are available on the GitHub. So if you want, you can contribute. Let's say you actually figured out a better way of doing certain thing, right? So you can always contribute to that, and we highly recommend and encourage you to do so. So again, this is all we have seen in action during last 30 minutes. So essentially, the next question is, hey, as a programmer, see, I showed you C# just to make a point. Next week we will be seeing Angular, right? We will be seeing a mean app which uses Mongo, right? I want to give everything to everyone a little bit here. Therefore, I use C# here, but I'm not proposing you develop in C#. You can use any language. Okay. So some of the popular ones are, most of you might use Java, Python, Node.js, Golang. Yeah, everything is fair, right? You can actually use our SDKs, and we provide these SDKs that are shown here. And now the question is, which SDK I use for MongoDB Cassandra API, right? So again, to the point I have mentioned, right? Why can't we actually build on top of someone else's work, right? So as you know, for example, Cassandra, MongoDB, they have actually very rich support of community, right? So Planet Cassandra and Mongo. So all of these things already, very rich set of SDKs are available. So why do we take the pain? We encourage you to take as much as, um, uh, those things into consideration when you are developing in those apps, right? So just I am making a point here. So as you can see here, .NET SDKs, you have V2 SDK, but we strongly recommend you use V3, which is the current release. It includes bulk support. I'll show you that in a little bit. And there is V4, which at the time of recording this session is in preview, but please go and check, if, when it comes out of preview. And it looks like it is planned for late 2020, which is very soon. So Java SDKs, V4 is the current version. And there is Node.js and Python SDK, okay? So they're up to date. So So actually for Azure Cosmos DB, I would argue, right? So why, like complicate our life with ORMs when we have this ability to directly commit our payload, right? Into the database, but still we actually, created a .NET ORM, right, for entity framework, wherein you can take advantage of that as much as you can. But for other things, you can actually use third-party stuff, right? For Java, you can use Hibernate and other things. But there's no need of it as much as you can, right? If you are taking advantage of SDKs, you probably might not need this. Then last but not least, for my Java friends, Microsoft loves open source. We actually love Java. Now we have Java support and Spring support available on Azure in form of Azure Spring Cloud. We actually maintain and manage the Spring clusters, the Spring Boot clusters for you, wherein you take the opportunity and use Azure Spring Cloud, wherein all your registry, discovery, etc. are maintained, managed in one single place, avoiding the need for you to create your own installations and maintaining the machines, right? So I would strongly recommend you please explore Azure Spring Cloud in the link that is shown here, which is a little bit out of scope, and as a separate call, we would be happy to go through Azure Spring Cloud. But for now, please know that Cosmos DB can be used with your Spring Boot application, and I think this week, even now, it is GA. So the the Spring Boot SDK for Cosmos DB, I think, is in generally available. I'm 99.99% sure, but I would highly recommend you cross-check that. Uh, so having said that, now let's switch gears and move to our next topic of how to utilize Azure Data Factory to move a lot of data from on-prem into Cosmos DB. So the typical use case here is, let's say you want to quickly move data from, let's say, on-prem data source, or from a comma separated file. Quickly you want to make it into a JSON and load into Azure Data Factory. And load into Azure Cosmos DB. There is this tool called Azure Data Factory for my data engineering friends on this call, if you want to check out. What that does is it will provide you with a no-code experience of moving data from one place to another place. And it is very important, right? Because you can avoid a lot of complexity using the code, such as bulk loader utilities and whatnot to move data from one location to another location. But I want to tell you that, the program has to be successful because this is all or nothing. Therefore, still you should be able to use bulk load. But for example, if you know that your data is clean and you don't want to do much transformations by the time you read and write the data, yeah, of course, this is actually a better choice, right? Because you don't need to write a single line of code. So let's see in action how Azure Data Factory and Cosmos DB work together. So I have this thing called Data Factory. So this is the Data Factory. And Data Factory contains something called pipelines, which we trigger. And here, in this case, if we go to authoring here, you can go to the data flow. Here, I'm just loading the New York taxi data set into a Cosmos DB container. A very simple application, just to show you how it works. So this is a no-code experience we have seen. You read the taxi data, looks like these are like bunch of Parquet files, and then you perform actually minimal transformations, right? Such as creating a composite partition key, right? For whatever reason we did. And then we did upsert and whatnot, and there are 51 columns, and we want to bulk load this particular thing. So now we offer the sink, right? The sink is of type Cosmos here, and this is the partition key, right? And let's say once you trigger this application, you go to monitoring, and within the monitoring, for example, this is the one I have run, and very easily you can see here, right? So I have read like lots and lots of data, 355 million records I have read, and I have read 13 million records into this, and with a reasonable resource usage, because I did not spin, like exorbitant number of RUs. With reasonable RUs, I was able to load in the specified time interval, right? Whatever time it took, I was able to load it into the Cosmos DB container. And this is an example of, a classic example of, how you can use our no code experiences, right? If you want to quickly move data from one place to another place. So please keep this tool called Azure Data Factory in mind. And we offer actually many sessions, whether it is on Channel 9 or at various conferences, the Azure Data Factory sessions, and our engineering teams did a very good job with a rich set of documentation on this tool. So then let's move to Azure Cosmos DB bulk data ingest. So in order for us to use bulk data ingest, we recommend you use Java and .NET SDKs for doing bulk ingest, because we have so many bells and whistles incorporated in those two SDKs. But only thing is, please make sure you turn off indexing before you start bulk load, because indexing adds overhead. Once you actually complete your bulk loading, then turn on the indexing again, right? So that's actually a good use of loading, and trust me, it will provide you X number of times better performance than otherwise. Please keep that in mind when you are performing the bulk ingest. Bulk ingest also uh, uh, increase the request latency, right? So also, this is not normal. So you don't actually do your day-to-day transactions. Bulk ingest is only for the very first time, right? So so please turn on the bulk ingest capability very judiciously, right? And only use it for bulk ingesting. The reason is, in bulk ingest, you have to maintain the checkpoints, you have to maintain other things, so that you do retries if you don't have enough resources. So all of these things, as you know, will add overhead for a regular operation. So with that, I think we have actually seen enough of bulk ingest portions, right? So these are again, please follow these links. And there are SDKs, there is a rich set of documentation here, and you should definitely be productive. So then let's switch gears, and for the last half an hour, we are going to concentrate on Azure Cosmos DB change feed and understand something called event-driven processing. This is very useful if you are developing your applications, especially in Internet of Things scenarios. So Azure Cosmos DB change feed allows you to listen to Azure Cosmos container if there are any changes that are occurring on that container in near real time. That is very important. Okay, just like how your transaction log is for your database, right? The journal. Here you have the change feed wherein, let's say, you insert or you update any record within your Cosmos DB, immediately you get that record within the change feed. So what is the advantage of change feed? The advantage of change feed is, for example, let's say you are a consumer of Cosmos, and let's say you want actually something to be known very immediately. Let's say you want actually, let's say in our example, you get an alert that your driver is speeding. You have seen last week, right, the application, in which you will see that application again, right? And I will, just to refresh your memories, I'll show that application again in next 2 minutes. So essentially we have this application wherein we are actually, if we go back to our Azure, so within our Azure, we have this app wherein we are a fictitious Contoso app. Let's go and check that. Okay, so let's go to this app. Yeah, just to refresh your memory, this is a fleet management app. We are Contoso. We are a fictitious company wherein we operate lots of vehicles, and we want to actually monitor our trips. So we actually, customers book consignments with us so that we can move packages from location A to location B. And when we are moving that packages, for example, at any point in time, we know for a given vehicle, right, what is a consignment, where we should be delivering that, in this case, to Tray Research, and how many packages are there, right? And what is their current status? And for example, if there are multiple refrigeration units within each container, we need to make sure the temperature is maintained consistently, right? And don't fall below the or above the thresholds until it reaches the customer. So in this scenario, imagine this scenario wherein a driver is speeding, or in the container, a refrigeration unit broke, right? Or the package is delivered. All of these are events, and we want to recognize those events immediately and take actions on those events, right? For example, in the case of the refrigeration unit breakdown, probably you might send another vehicle to that place to pick up to pick up the consignment and transfer into that vehicle. Or, if the driver is speeding up, probably you'll write them up. Who knows what actions we take, but we have to take an action in near real time. Keep that in mind. So as a consumer, there are different consumers in my organization, because the guy who is responsible for disciplining the drivers or monitoring the drivers might be different from a woman who is monitoring packages, right? To ensure the quality control so that the packages are delivered to the destination under right circumstances. So the gentleman and the lady are consumer 1 and consumer 2 in our application, right? As they are monitoring the systems, right, they will be looking, right? So those applications, right, that are responsible to capture these changes, they will be constantly listening to that change feed. Keep it in mind. Then, so this change feed tracks inserts and updates. Then you can ask, what would we do with deletes? fine. A delete can always be maintained as a soft delete, right? So you can always put a delete as you update actually a delete flag to Y, right? And in which case you will update the document. Your change feed has the document and set the time to live on that document so that you expires, and after time to live, you will expire the document and the document is gone. So please maintain deletes as soft deletes so that you can update a delete flag and you can expire that delete flag after certain period of time. And that is possible because of time to live option we have on these databases, which is an excellent option. So in change feed, only the most recent change is present. Order is guaranteed within a partition key value, which is important, right? Why is it important? Let's take an application, a retail application, wherein you go to shop to, let's say, contaso.com, and we sell a lot of products. So you add 3 products and then you add them to the cart. You go to the checkout, but you realized, oh, you know what? I just don't want to add this product, but put it in my wish list and then remove it from the cart and instead order 2 items. So now, as you can see in this rather simple flow, there are many things, right, that can happen between one event and another event. And if you don't order them in that timestamp order, you will miss what happened first and what happened next. And therefore, it is very, very important. In our case, assume very simply that, let's say, customer is the partition key. So for that customer, let's say customer and month is partition key. So for that customer, for that month, let's say whatever they are doing, we'll maintain that in the order within a partition. So so this isn't a duplication of data already in the container, because remember, this is like kind of a journal, right? It supports multi-region accounts. It is enabled by default. You don't need to do anything. And only if you use change feed, you will be charged for our use. Okay. And also, please remember that when multiple consumers are operating on the change feed, we actually provide a lease for every container, so that the lease contains, which partition the consumer have read and up to what point the consumer have read. So, and for which you need a container called a lease container, and you will pay nominal charge for that. So this is an example of event-driven architecture. So you have multiple sources. All the data is coming from these multiple sources into Cosmos DB. And then there is a change feed on top of that, as I explained. And from that change feed, you are triggering, right? You are triggering something. So a consumer can be an Azure function, correct? A consumer can be, an end user who receives a notification. Or it can be anything, right? So a consumer can be anything. A consumer can be a Spark job that actually performs a data science activity to detect, for example, let's say an anomaly, right? So in some cases, believe it or not, a consumer can be, like another storage account. For example, let's say you want to move all the data which is older than 24 hours into a cold storage. You can actually do so, right, by utilizing this change feed. Think about it. And that's why these are all 3 different scenarios which I want to actually touch and explain upon. So in event-driven architecture, we use mostly Azure functions, right? These 3 components wherein, for example, in our case, right, the temperature threshold has reached, then immediately notify the supervisor of such an activity and they'll take an action, right? So Azure functions can use Azure App Service. Then there is the stream processing. So this happens usually in the data analytics world. For example, let's take our case. In our case, let's say we want to actually run a stream analytics job that performs a windowing function. Let's say we want to actually average out the speed during 5 minutes, right? And if speed is greater than a threshold, we need to actually make a decision. So Azure Stream Analytics is Stream Analytics as a service wherein you can design these kind of aggregations on the time windows. That's a typical example of how you can achieve that. And like I mentioned, if you want to move the data from one collection to another collection, or if you want to move hot data into, let's say, a very cold data kind of scenario into a storage blob, that is the third way you can use change feed. So now let's talk the event-driven architecture a little bit, and I want to show you certain things. So one of the things that we can use definitely, right? So there are many things we can use in order to read the change feed. Of course, the first and foremost, we use change feed processor. So change feed processor library is what we call it. Okay. So change feed processing library hides most of the complexity from the end user, right? Because we take care of all of those things, right? We provide utmost control for push scenarios wherein we can read the change feed. And also we will automatically divide the load among different clients. We guarantee at least once a delivery for every consumer, like shown on the right hand side. For example, like you have the host 1 and host 2. Think of host 1 as a virtual machine and host 2 as a virtual machine. And let's say you want to achieve parallelism by creating two virtual machines in this case. And there are two consumers and both of them want to use the power of both machines in order to read the Cosmos change feed. And there, as you can see, there is the lease collection in the middle, wherein it is maintaining a continuation token, right? Like kind of a checkpointing, and it also says who is the owner, who is reading this, who is doing what. Basic information will be there in the lease container. I'll show you a lease container in a bit. And then we actually, then you can run the change feed code from all these hosts so that we will guarantee at least once we will deliver that to your consumers that are running on different hosts in this case. So change feed processor is one of the push technology which you can use with all bells and whistles, right? Incorporated already in that, and as a programmer, you can take that SDK, advantage of that SDK. But Azure Functions provide a similar concept as that, but this is the nuance. You don't need to write a single line of code. We provide something called a trigger on an Azure function. And guess what? Change feed is the first party trigger. And that trigger has all the abilities of the change feed processor. This is the very simple option. If you are using an Azure function, it automatically parallelizes how you have seen here. You don't have the headache of spinning up hosts. Azure function takes care of spinning up n number of hosts for you as needed. All you need to do is just consume it using that Azure function. And it uses change feed processor underneath the covers. And the only thing you need to know is if you have to use the core API in order to use the function bindings. However, we do understand that you need a lot more control, right? Here, you're feeding off of the partition. But what if you want more control within a partition? And what if you want to read from, let's say, token 1 to token 10? That's all within a partition. And you need that kind of control. So we have something called pull model incorporated in our .NET SDK v4.x, which we spoke about. And you can definitely use .NET SDK v4.x in order to do pull models, right? That would be actually push versus pull, right? But please know that it contains added functionality, added complexity, and you need to know what you're doing before you use that. Okay, so I strongly prefer Azure Functions trigger, followed by change feed processor, followed by pull model, if you ask my opinion. Let's see change feed processor at a little bit more depth. So there is this monitored container, the container so from which the change feed is generated, right? So the change feed is in that container. But before we read that container, we need to actually have the lease like we discussed, and you can see here, and the host we already spoke about. And then there needs to be a delegate, okay? So in change feed processor, you have to implement the delegate logic, without which it's meaningless, right? So a delegate is the workhorse. So what it essentially does is that piece of code literally takes action. In our case, if the temperature reaches the threshold, right, send a notification is an example of a delegate code. So the change feed leases container operates as follows. Let's say in modern world, we operate using microservices. In the microservices architecture, let's say every microservice is reading a Cosmos partition. And as you can see here, the microservice one is reading document one in partition one and so on and so forth, right? So we create a bookmark. So if you see the lease container and if it is processing this record, and this is how it bookmark internally. Right. So again, this is the physical partition per container per microservice like this. And then it keeps going. And let's say the microservice 2 joins, and which is what we called consumer 2, if you remember in the previous slides, right? So the next microservices come and the lease will maintain its own thing. Now, this is how the code looks like, okay? So in the code, what you have to do is you have to tell what your the source database is, what's the container, what's the, you should have a lease container. So what's the lease container? And then what it does is you just say that, okay, this is the change feed processor, instantiate it on that particular container, instantiate the change feed processor, right? With the lease container, and you do dot build, right? Okay, that returns the change feed processor. So next, with this change feed processor, your delegate, right? This is what delegate is. Your delegate will take an action on that. For example, here for each to-do item in changes, right? You are actually doing something here, right? Who cares what you are doing, but you are doing something. Uh, so there is actually, a change feed process estimator, which you can use. Um, I will let you read the documentation for this. Uh, they go hand in hand, the change feed processor and the change feed processor estimator, so that you can actually monitor everything to the extent that you want it to be, right? So you can actually go through the documentation. I don't want to go too much into this today. Let's jump into functions. So functions, the same concept, right? Here, instead of one microservice, let's say the 4 microservices are running. There are 4 different functions, right? There's a lease container, there is a delegate code, and so on and so forth. So this is an example of a function, and in the function, as you can see here, there is the Cosmos trigger. Like I said, the Cosmos trigger is inbuilt, and then you implement your logic within the function as a delegate. Your function is your delegate, and the trigger is your change feed processor. Okay, so Azure function automatically checks container for changes, and you have a setting called feed poll interval, and once that poll interval is reached, it will check again. Um, and it processes, let's say here, the document, and Azure function again checks and finds document B. It processes it. It does not find any changes. It waits for feed poll interval before it checks again, right? So, and then again it checks, and now it has document C. It reads document C. So some of the attributes of the change feed are you can automatically create lease collection if it does not exist. You can tell it from where to start, right? Start from beginning, starts all the way from the beginning. And then you maintain the leases so that when next time the function for any reason it comes, it goes down and it comes back again, whether you switched off or switched on. It knows from where it needs to process, and then you can actually create a delay interval. You can also configure how many items to get per invocation. Okay. So, but only thing you need to remember, right? This is the nuance between change feed processor and Azure functions. In Azure functions, right? Unhandled exception in delegate code will not be retried. You are responsible for retry logic. You handle all the exceptions and you retry, and you write it to a dead letter queue. Okay. In change feed processor, right? Unhandled exception will result in failed changes, right? And they will be retired until processed successfully. And this way, it helps the program not to get stuck while it is retrying, right? And also, you can actually add the logic, right, to read the failed changes and put it in the dead letter queue, which is no different than Azure functions. But I hope you got the nuance between these two, and please make sure, right, when you are using Azure function, all you need to do is please make sure you do the retry logic by yourself. Then let's say intermediate updates, you are interested in the intermediate updates. Remember, we said Cosmos DB, it handles only the most latest change. What happens to the intermediate changes? And you need all of them. Handle them as inserts, which is the very common format. So in event-driven architectures, it's very common that we put telemetry, we put all telemetry in, and we don't let it update or upset in the Cosmos DB. So AKA what I'm saying is, when you are pumping records into the stage table, put everything in, and then read all of those in the order that they are received, and then use a Spark compute or an Azure function, and then make a decision and put it into your final collection. That is the way you deal with intermediate updates. And already we spoke about deletes, wherein you create a soft delete flag with time to leave option. So this is the illustration of change feed pull model. So in change feed pull model, right, you get a lot more control of, where you need from where your iterator starts within a given partition. Okay, and therefore we introduce here the concept of feed ranges and feed range per partition. So this is very important, right? So in machine 1, you do range 0. In machine 2, it is range 1. And you have to make sure, right, you provide these feed ranges, and everything orchestrates in a well orchestrated form. That's why I said, when you are using the pull model, it is like little bit more complex than using the plain change feed processor. But there are genuine scenarios, like I said, you might need to use wherein you have utmost control on when you need to fetch the data and how you need to fetch data, and you need utmost control on fetching your data, and then you need to use pull model. And this SDK, it's well documented, right? So yeah, it's same, the concepts are same, but the only thing that is different is the feed range, the concept of feed range. And please go through the concept of a feed range. So in our context of Contaso, in our use case, right, our vehicles deliver consignments to customers, and we want to track the vehicle and delivery status in near real time. And therefore, we built a web app, right, to see the status. Now, of course, you know where I'm alluding towards. So you need actually a Cosmos change feed to accomplish that. Let's see the simplified architecture that is shown here, wherein, let's say we write an Azure function. And what the Azure function does is, the Azure function, it recognizes a change feed. It uses a component called Azure Event Hub, wherein the stream analytics interfaces with this event hub, and it renders it performs the windowing functions here and puts on Power BI so that the logistics managers can see the data. At the same time, an Azure function want to send a notification based on some criteria to someone. An Azure function reads the same change feed and it uses an Azure Logic app and it can send an email notification to the end user. And also, next week we will talk about analytical use case and Synapse Link. So for this week, let's not touch Synapse Link. So next week we will talk about Synapse Link, but this week let's just concentrate on the change feed. Let's see actually some code, right? So I promised you that we will see some code of Azure functions and how we use Azure functions with change feed, etc. I'm just checking if I didn't miss anything here. Change feed in context. Okay, so with that, I think today we covered most of the portions within the change feed. I would say all of the portions within the change feed. So we will go back and see what all we have discussed now